All right, Geometry Summer School. Again, we're looking at Unit 3. This is Part B, I guess you could call it. But this is where we really get into the triangle congruence stuff. And key word here is that things match. Pieces correspond. Correspond. That's the idea. You're going to see like what corresponds to what, or corresponding pieces, but what does that mean? It just means matches. Okay, so complete each congruence statement. That means that these two things are the same, but not only are they the same, but they're the same in a very specific way. And that's made here by this statement. So if I were to look at this, let's say I were to kind of match these, just so I can confirm here. W, V, U. Well, W is like the little double arc here. That's like 2, and then V is 1, and then this is 3. And I just want to make sure that this goes in the same order. So V, W, X for the other one, that's a 2, then a 1, then a 3. So that's, you know, if that was in a different order on one of these sides, not on necessarily both of them, but if it didn't go double arc, single arc, triple arc, double arc, single arc, triple arc, you know, matching that way, then it would not be a congruent statement. You wouldn't have the same there. It could be 1, 2, 3, 1, 2, 3, 3, 1, 2, however you want. There's 6 different ways you could do that. But the idea is that they match. Keyword. So in this idea of matching, we got to match also specific parts. So when it says line segment UW here, that's from U to W. So let's color this in blue just so you kind of know exactly what I'm talking about. This one right here, that's the triple mark. You see that? So I need to look for the triple mark over here, which would be this one, and that's XV. That's the one that matches there. So XV, boom. Then you're probably asking, wait, could it have been VX? Yes. Why? Because line segments are kind of interchangeable on their endpoints there. All right, now this next one, again, it's the same idea where you're just trying to match the pieces to it. So I see IHG here, IHG, so IHG, that's the double arc. So I'm looking for the double arc over here, which I could say is HI, ooh, I think this is an S or SIH. So it's either angle HIS or angle SIH. Why is it either one? Because both of them represent the double arc right there. So either one of those could have been correct. Something else would not be correct. Now you might be thinking, oh, that's like so much to think about in this picture, and I got to see the pieces and make sure that they're marked. It's actually even easier than that. All you have to do is match these letters. So if you look at UW, that's like a 3 and then a 2. So all I have to do is go to the other piece of this congruent statement and go 3, 2, the last one, and then the first one, and then boom. That's it. Same thing over here. IHG is like 1, 2, 3. So then we go 1, 2, 3, and HIS, and boom. There's one of our answers. So does that not make sense? Let's try it again. Let's do it more. All right, let's do another one here. WXY and IJK. So WXY, IJK. I see WX, which is like the 1-2 punch, so I need another 1-2 punch, and that's congruent to IJ. Boom. That easy. These weren't even marked, and they were almost easier because it's less to think about. I'm not really focused on all the markings. Just the correspondence, the matching. Okay, angle U. Well, angle U is the third one here. So that's going to match the third one here, which would be angle A. It is that easy. Did I even look at the pictures? No, I didn't. In fact, in these next ones, we don't even have the picture. We just have to get it just from the statement. So look at this. I got like 1, 2, 3, 1, 2, 3, and it goes 3, then 1 for KI. So then I got to go 3, then 1 for the other one. That would be QI, and it's a line segment. Boom. Done. Do it again. RST 1, 2, 3, JKT 1, 2, 3. So now put these together in the right order. So we got TR, that's a 3-1 combo, so 3-1. So then I need another 3-1 combo over here, which would be TJ. Boom. Done. It is that easy, guys. Just look at your matching pieces and pick the pieces that match the one that was given to you. Here we go. Do it again. Mark the angles and sides such that a pair of triangles to indicate that they are congruent. Okay, now is a little bit kind of like the other way. Like, can you visually communicate the congruence in the triangle? Not just by the letters and the symbols, but visually with the pictures. So IJK, that's like 1, 2, 3, 1, 2, 3. So I'm going to give a single arc, J a double, and then K a triple. Perfect. Similarly, TRS, so that's going to be a single, then a double, then a triple. Now to keep things simple, it doesn't have to be this way, but to keep things simple, I like to go across to get the marking that matches. So if I have a single arc here, I'm going to go across to JK and do a single tick mark. Similarly, the double arc, I'll do a double tick mark there. And then triple tick mark will be across from the 3. 1, 2, 3. Why would I do it so structured like that? That makes doing the second one that much easier. Across from the 1, 1. Across from the double, 2. Across from the triple, 3. Boom. Done. Sweet. Let's do it again. Same idea here. Okay, so DBC, I'm going to go 1, 2, 3, 1, 2, 3. DBC, so D I'll do as my single, B is my double, and C is my triple. Okay, so then the other one, D again is the single, then K is the double, and J is the triple. Alright, okay, here we go. Now we got to add in the tick marks. So I'm going to go across from the singles, across from the doubles, and then across from the triples. It was that easy, guys. That super easy. F, G, H. 1, 2, 3, 1, 2, 3. So we'll make F the single as well as the H. Then G will be a double as well as the S. And then R and H will be triples. Let's put in the tick marks to match. Done. Move on. It's that easy, guys. It's just communicating that you understand visually where these markings would be. Now, you might be asking, did it have to go in that order? 1, 2, 3? No, I could have gone 3, 2, 1, 3, 1, 2, 1, 3, 2, 2, 1, 3, 2, 3, 1, or the 1, 2, 3. Any one of those works. There's 6 possibilities. I'm just doing 1, 2, 3, 1, 2, 3 because that's simple, straightforward. But I could have done any one of these combinations. What's the key all day long? Match. Whatever you do first, you also do second. Okay. Let's keep going. Write a statement that indicates that the triangles in each pair are congruent. Ooh, all right. So it doesn't give us something, but we're going to have triangle something, something, something is congruent to triangle something, something, something. Again, there's 6 different answers here, but as long as we match them, then we're fine. So let's do the 1, 2, 3 again. So let's do this. This would be C is 1 here, then B is 2, so that's C, B, and then D for this triangle in the top left. Now for the other one, I gotta go 1, 2, 3. That's C, B, I. So C, B, I. Too easy. 1, 2, 3, 1, 2, 3. Again, triangle something, something, something is congruent to triangle something, something, something. Let's just do the 1, 2, 3. So for the first one, we got L, M, and N. Okay, is that the right order? Yeah, here we go. 1, 2, and then 3. So L, M, N. And that means over here I'm going to go 1, 2, 3. So L, D, B. L, D, B. Again, keyword, match. Is that it for this one? Yep, that's it. Let's move on to the next one. We're doing really great here, guys. This is a very quick video. It's mostly about communicating match. Okay. Okay. Now we're into the crazy stuff. Okay, so if everything matches, everything's congruent, no problem. However, There's some matching pieces that we can say. Two triangles match each other. They correspond to each other. They are congruent to each other if they just have partial matching. Partial is enough that you can assume the rest because the rest could be proven. So the partial matches we could have are all three sides. We could have an angle in between, so side, angle, side. Oh, and then we could do the angles with a side in between. And then we could also have two angles and then a side not in between them. Now the last one, which is kind of weird, it's side angle, but not really. It's side angle, but it's hypotenuse leg because it's right triangles only. This only works for right triangles. If it's not a right triangle, it doesn't work. So what is not congruent? Well, angle, 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 that doesn't work. Or if it's just angle, angle, same thing. Or angle, angle. Because if you have two, the third one's kind of still there. What else could we not do? Well, the side angle, when it's not a right triangle. So if it's not a right triangle, then side angle wouldn't work. Alright, so let's see what we have. We got a right triangle here with a hypotenuse and a leg, which actually is enough, hypotenuse and a leg, because it's side angle. Here's our side angle. Side angle. But it works because it's a right triangle, so we call this hypotenuse leg. Alright, now this next one, I got an angle and then another angle. I don't have any sides. That's a problem because this third one, even if I wanted to use it, this vertical angle relationship, that's just angle, 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 and that's not enough. That is not enough. So not necessarily congruent. Maybe, but it's not proven. Alright, let's take a look at this next one. I see an angle, then another angle, and then a side. See, I'm going kind of in order here because the side is not in between. Alright, let's see if it's the same thing for the other side. It goes single, then a double, and then the double side. Is that right? Angle, angle, side, and it goes in the right order. Yes, it does. It matches. So yes is congruent by angle, angle, side. Alright, so again, we're just focusing on the visual kind of, can we see the congruence? And these right here, these are key. These are key. We're going to keep coming back to those. In fact, let's take a picture of them. And so we can paste them if we need to later. Alright, now let's do it again. Same idea. But this time, I'm going to tell you what I'm looking for, but something is missing. What additional information? Alright, so it says angle, angle, side. I see angle, angle, side. Well, I got the side. The side is side LK. And the first angle is angle J, but it's missing the one in between because look, I could either go up to here and then down, or I could go down to here and then up. I need an angle, really. So there's actually two answers to this one. It's kind of weird. So I would need the angle K matches angle E, because that would kind of complete the chain here with angle, angle, side. Again, angle, angle, side. Or I could have said F and L, or L and F. So either I need to say that angle K is congruent to angle E, or the second angle could have been angle L is congruent to angle F. Both of those would work, because that would have been a second angle before I hit the side. Now I couldn't crisscross these. I couldn't say K with F or L with E. We do have to go in the same order. Alright, side, angle side. Okay, so we got a side that matches. And there's another side in here that is not necessarily easy, but it's the shared side. It's this one that's in between. We call that a reflexive property because you see itself, and when you see yourself, you're like, hey, that's me. That's the same thing as I am, so they go together. So notice I have these side and side. So then I have to have an angle that's in between. The angle is in between. Okay, so that angle then is going to go right here because that's the only angle that's between those. So that means that I have to say angle CDE from this triangle is congruent to the other angle VDE. Booyah. Alright, let's keep going. Number 77 here. It says angle, angle, side. Okay, so I have two angles that match. And it goes HG. Well, then I need to either, let's say I started with H. Let's call this my first angle. So that's like A1, and this is A2. Then the side needs to be after that, which would be right here. So let's say I started with GI. Again, look, I went with the triple arc, then the double arc. So I got to do the same order over here. The triple, which would be E. So this is my A1. And then right here, F is my A2 because it's the double arc. I went triple arc, double arc, same order as before. Then the consecutive side, the one following directly after that would be here. FD, that would be my side. So this would be congruent, GI would be congruent to side FD. Could I have done that differently? You betcha. If I reversed the order and went double arc then triple arc, then I would have had HI and ED matching. So I could have had the other matching, HI and then ED. Notice that there's a little bit of flexibility here. When it goes angle, angle, side, where the odd one out, in this case the side, is not in between but outside of that, it could have been before or after those two angles. You know, I could have gone down here to GI or before it to HI. And it doesn't really matter when it's not in between. But when it is in between, like number 75, when you have the angle in between, there's only one angle that sits between the two sides that are given. I can't choose the other two. There's not as much flexibility there. Okay, let's keep going here. Let's look at number 79. Find the value of x. Okay, this should be a piece of cake. My goodness. You see that those two are congruent, and these two angles are congruent, and hey, wait a second, this side in the middle is congruent. So these two triangles are congruent, which means they have congruent parts as well. So if I were to look at this 6, it's across from the single arc, then this x across from the single arc should be the same. So x equals 6. Wow, that was easy. Okay, let's do another one. Alright, so I see this single side is across from this angle, and this single side is across from this angle. That means that those two angles are also matching. So this x is the same as this x. So actually I have x plus another x plus 92 degrees. Why am I doing this? Because inside the three angles of a triangle, the interior angles add up to 180 degrees. So I can add those three up. Let's do some subtraction. Subtract 92, 92. Subtract 90, that'd be 90. So I subtract 2 more than that. It's 88. And over here I can combine these two x's. That would be 2x equals 88. Keep going to figure out x, y, because that's what they're actually asking us to do. And x equals 44. No big deal, easy breezy, lemon squeezy. Alright, for this next one, a lot of people would do this again. They'd say, oh, it's x plus 49 degrees. No, that's not what's happening, because look at the arrangement of angles here. Across from this single arc and this single arc, the two angles are congruent because it's isosceles. It has a line of symmetry here where everything kind of balances on either side. So this is more straightforward than the last one. This one is 49. Hey, guess what? So is the other one. X equals 49 degrees. So you got to be careful. These are both very similar images, but different calculations because it's really based on what pieces you're given and how you would relate them to each other so you can make a calculation. Let's look at a few more here. Oh, here we go. All right. So first, immediately, this is kind of interesting. That's 90 degrees there. All right. I'm probably going to use that. All right, let's look at these angles. Isosceles triangle that's symmetrical across this line because this angle matches that side and similar there. So this is 70. This is 70 right here, these three. Now to find this x, it's not obvious, but we need to find this one here. So I'm going to call this a question mark. And I know that 70 plus the question mark equals 180 because those three make this triangle kind of in the top piece here. That's 140 plus a question mark equals 180. So this question mark, whoops, 140, not 144, is going to be 40. When I subtract 140 from both sides, I get it equals 40. How is that helpful to me? Well, if that's 40, let's redraw this angle here. This piece is 40. Together, they're 90. So now, what would x be? Well, x plus 40 equals 90. Booyah! X equals 50. Piece of cake. Okay, let's work on the next one. So I got to get to x. But to get to x, I got to work all my way through these. I actually have to find out every other single angle. So let's do that. Well, again, let's look at the bottom triangle. I got symmetry splitting this here. So 72 on this side means the other side's also 72. Let's call this angle right there y. Why? Because, well, let's see this. Y plus 72 equals 180. Do some math. The 72 plus 72 is 144. So y plus 144 is 180. If we subtract 144 from each side, that would give me 36. Okay, so this piece right there, that's 36. Hey, wait a second. If that's 36, so is this one. Why? Because they are vertical. All right, now I'm ready to start calculating the other triangle. It's like I had to do each triangle separate. This one, again, has a line of symmetry, like the other one. Here's 36 degrees. And so is this one. It's also 36 degrees. Why? Because it's an isosceles triangle with that symmetry there. So I got 36 and 36 and x, and those three make the top triangle. So I'm going to put those three together. 36 plus x equals 180. Alright, 36 and 36 is 72. Subtract 72 from either side. And we'll have x equals, let's see, what are we going to get here? 108. 108. 108 degrees. If that didn't make sense to you, you should watch it from the beginning again, just to rewind a little bit. But I need to move on to the next one here, number 89. Okay. Whoa. Whoa. Let's check this out. Okay, I got 132 degrees here, but together with this straight line, the inside piece is going to make 180 because that's a straight angle there. So 132 subtracted from 180 should give me this first angle. Why would I do that? Because I want to start with the number and then work my way through the triangles to get eventually to the x. Okay, so I got 180 minus 1, whoops, minus 132 is 48. Okay, so that means this right here is 48. Alright, now if this triangle has symmetry, that means that these angles down are going to match the other two angles down here. So this one and this one are the same. I need to do something. Do I even? No, I don't even need to figure that out because that doesn't even help me. What? Pause, reverse just a little bit. Check it out. 90 degrees. Why? Because it's a right angle. And if that's 48, then this here is going to add up to 90. So 90 minus 48 is going to give me 42. So this is 42. Now, this is awesome. I'm done because look, now I got the symmetry going across. So this matches that, and this matches that, and those are congruent, so that means that x equals 42 degrees. Booyah. This next one's pretty similar, not exactly similar, but it actually has a couple more calculations added on. So let's start with a straight angle here, 112 to whatever this would be, which is 180 minus 112, because straight angles add up to 180 degrees. That would be 68. So this is going to be 68. Thankfully, we have some symmetry here. This matches there, so that's going to match there, so that's also 68 degrees. Now, all together with those and this top one, let's call this y. Those should add up to 180. So 68 plus 68 plus y equals 180. Add the 68s, and that's going to be 136 plus y equals 180. Subtract 136, y equals 44. Okay, so up here this is 44 degrees. But this up top happens to be a 90-degree angle, so the other part here, this is going to be 90 minus that 44 degrees, because it'll be the leftover. So 90 minus 44 is going to be 46. So that's 46. Oh my goodness, this is a lot of action. So that's 46, and because of the symmetry, these will add up to 46. Now, here's at least something for us. I don't have to, I could find this third angle and then figure out that it's subtracted from 180 degrees. But I noticed something here. Look at this. I got two remote angles and an exterior angle. And I know that those two remote angles add up to the exterior angle. So those are 46 plus 46, which is going to give me 92. 92? Yeah. Yeah, 92 degrees. So this x right here is 92 degrees. Excellent. Now, if I wanted to do it the other way, I would have said 46 plus 46 plus something equals 180. And then I would have got that's 92 plus something equals 180. And then I got that something equals 88. And I say, oh, okay, so this is 88 degrees. And then I'd subtract that from 180. And you would get, hey, 92. Wait, extra steps. Didn't have to do that much. But I'd still get the same answer, whether I did it one way or the other. Ooh, we're almost done. Look at this. Page 23 of 24. 2 more pages and we're done. Ooh, all right. So we got algebra mixed into everything now. Let's see what's happening. So I got some symmetry. Here's where the line splits. Go across and across. That means that this angle 2 up here is the same as this angle 2 down here. So this is angle 2 is x plus 46. And I know that if I added all three of those together, then I would get 180. So x plus 46 plus x plus 46 plus 102 equals 180. This is one possibility. The other possibility is, let's just figure out what the number is, the numerical calculation for angle 2. Well, if this first one is 102, that means I could subtract 102 from 180, which I'm going to do anyways. So let's just figure that out. That would be 78. And now I got 2 of this angle. So if I split that in half, that gives me just one of them. Let's go ahead and just work it out here from what I got. So I'll have 2x, because I got 2 x's. 46 and 46 makes 92. Hey, didn't we just do that? Yeah, we did. That's kind of interesting. So subtract 92, and you would get, oh my goodness, 80 minus 94, negative 14. So this is kind of weird. You get a negative number, which doesn't happen a lot in geometry, but it's still valid. It's okay, because when we plug it back in, we would get different numerical answers here. Because if x is negative 7, and then we add 46 to that, then we get 39. So this is 39. And this is 39. Is that right? Yeah, that is right. Cool, cool, cool. Hey, this is kind of interesting. Let's see what we got going on here. So this is 102, but notice it's an exterior angle, and the two remote angles here would add up to that. And these two remote angles happen to be the same because they're opposite, or not opposite, I shouldn't say. You know, they're like the balanced sides of equal symmetry in the isosceles triangle. Okay, so that means that this is 9x minus 3, and this is 9x minus 3. And according to that exterior angle thing, where you take the two remote angles, the far away angles, they add up to that one. So that means that 9x minus 3 plus 9x minus 3 equals 102. Boom. So that's going to give me 18x minus 6 is 102. Add 6. And I get 18, x equals 108, divide by 18, and then we got x equals 3. Booyah! Are there other ways to do that? Yes, there are. For example, if I were to just figure out what this angle was in numbers, it would be 78. Then I could have said 9x minus 3 plus 9x minus 3 plus 78 equals 180. But then I'd subtract 78 from both sides. And guess what I would get? I'd get 9x minus 3 plus 9x minus 3 equals 102. Hey, surprise, surprise. So whether you started with the interior angles equaling 180 or the exterior angle shortcut where the two remote angles equal the exterior angle, you would have still got the same thing. Same thing, no matter what. Okie dokie dokie. Let's move on. Last page. Whoa. Look at these. These are crazy. All right. Let's start with what I know. Okay, so this is 136. And I know it's a straight angle with this one, so I need to subtract from 180 to get that. Back, take one more back. Subtract 136 from 180, and I get 44. So this right here is 44. And cool for symmetry because that one matches that side, which means this side matches over here on the isosceles triangle. So that's 44 degrees as well. And hey, whoa, check this out. Vertical angles, which means they're congruent. So this is 44. And hey, whoa, check this out. Symmetry. Those are congruent. So this is 44. And check this out. Exterior angles. These both are the remote angles, so they're going to add up to this exterior angle there. That means 44 plus 44 equals measure of angle 2. Wait a second. Oh, so it's asking, it says this, and it's saying solve for x. Okay, well, let's figure this out. This is going to be 88 equals measure of angle 2. I thought this was easy, but now I got some algebra to do. 88, then I'm going to substitute this measure of angle 2 here for its algebraic form, the 15x minus 2. Because now I have to figure out what x is. Well, I add 2, I get 90 equals 15x, and when I divide by 15, I should get, it goes in there 6 times. Because 30 goes in 3 times, so 15 goes in 6 times. So 6 is x. Boom! Alright, I have a feeling that I'm going to have to do the same kind of thing for this next one. So let's do it. Purple. 106. This makes a straight angle here, so if I subtract that from 180, that should give me the inside piece of it, which in this case is 180 minus 180. 80 minus 6 is 74. So that's 74. And according to symmetry, look at these little crisscross actions. This other one's going to be 74. Now, I need some more action, so let's call this piece here y. And I know that those two 74s plus y add up to 180. Let's do that. So 74 plus 74 plus y equals 180. So that gives me 144 plus y equals 180. I'm going to do a little bit of mental math here. Y has to be 36. Because 144 plus 36 equals y. Now here's a cool thing. let's call this Z. Y and Z put together make 90 degrees. And if that one's 36, then I got to subtract 36 from 90 to figure out that the Z. And that would give me 54. So this side is 54. All right. So if that's 54, I got to keep going with more and more letters. I'm going to call this W. Why? Because W plus 54 is 180. So W plus, whoops, not W, W. W plus W plus 54 is equal to 180. So now I'm going to subtract 54 from each side, and I get 2W equals, what's that? I don't know, 26. Yeah? No, 30. Is it 36? 136. 136. 136. No way. No, 126. Yeah, I was right. With the 20 part at least. 126. Okay. Again, divide by 2. Alright, so divide by 2, we're going to get 63. So W equals 63. So this is 63 degrees, and this is 63 degrees. We are almost there. Almost there. But notice this last straight angle here. I'm going to pull this down and do it down here, because this is 63. So to find this outside piece, that would have to be 180 minus 63. So 180 minus 63 is how much? Well, that's 20, nope, 17. 117. So this out here is 117. Sounds like we're done, right? No, that's the crazy part. Measure of angle 2 actually has this big fancy equation on it, and then we got to solve for x. So that is equal to 14x minus 7. Now we are ready for the finale of algebra. I'm going to add 7 to both sides. That gives me 14x equals 124. Now as I'm looking at this, I almost feel like, man, did I miss something? Something off. It feels like something's off because I'm not exactly the same as what it should be. Let's see, we got 54. That looks right. 74, 74, 36. 4, 4, 6. Second. Man, I made a big mistake right at the beginning. 148. 74 and 74 is 148, which doesn't make this 36. It makes it 32. And that's not 54. That's 58. My goodness, this changes everything. And these are not 63. They're not 63. They're 61. There's so many changes happening. So this is 61, and that's not 117, that's 119. All right. Now we're ready because these numbers will come out better. 119 plus 7 is 126. You guys might not have known. Why? How did you know that you made a mistake? Well, here's why. Because 14 times x equals 120. Was it 124? That does not go in evenly. I know it doesn't. But I know that it does go into 126. So I was going to get an answer with like a fraction or decimal in there. Everything's a fraction or decimal. But with something that does not divide evenly, so yeah, it wasn't going to work. But I know that this goes in 9 times. So x equals 9 for number 99. Go figure, somebody probably would have just guessed that. But that's a lot of algebra, you guys. We have 1, 2, 3, 4, 5, 6 equations that we had to go through just to get the calculation. That's like 6 problems in one, but we got it. X equals 9. All right. Hopefully you guys do well with this. Good luck. Keep studying. I'll send out the message that this video is being posted. And spread the word. Have a good day.